even and odd functions. Our objective for this video, we want to identify even and odd functions and recognize their symmetry. So some functions can be further defined as being even or odd depending upon their symmetry. That's what we're going to do here. Of course, symmetrical functions are going to be reasonably rare. Depends on the function you're working with, but this is another way to further define a function if it happens to have symmetry. Okay, well, we know two things. We know what a function is. It's a relation in which each component of the domain, each input value, each x value, corresponds to exactly one component of the range, output value, or y value. And number two, the graph of a function may be symmetric with respect to the y-axis or the origin. We saw in a previous video, as we tested symmetry, that you can also have x-axis symmetry in some cases, but that is, I don't believe there's any x-axis symmetry when you're dealing with functions, okay? I think functions can only have either y-axis symmetry from the right to the left or left to the right, or origin symmetry, put a tack at the origin and spin it around. Okay, so we're going to focus on those two. Okay, we're going to remember how we tested those algebraically. Functions that have graphs that are symmetric with respect to the y-axis or the origin have special names. Okay, well, an even function. If it's a function that is symmetric with respect to the y-axis, it's called an even function. Okay, graphically, we're looking to answer the question, is the y-axis a line of symmetry? If the y-axis is a line of symmetry, then yes, it is an even function. Algebraically, as we saw in a previous video, we're going to substitute negative x in for x and see if we get the original equation. Okay, if a function is symmetric with respect to the origin, we can also call that function an odd function. Okay, so an odd function is a function whose graph is symmetric with respect to the origin. Odd origin, if that'll help you, okay? That's a little mnemonic. If this function is an odd function, it is symmetric with respect to the origin. Graphically, as we've seen, if you spin the graph around the origin, does it land on itself in less than 360 degrees? Put a tack at the origin, spin it around. If you can have it land on itself in less than a full circle, it is symmetric with respect to the origin. Algebraically, as we saw in a previous video, we're going to substitute negative x in for x and negative y in for y to see if you get the original equation. We're going to do both. We're going to look at graphs and we're going to look at equations. Okay, obviously the graphs are the easier ones, so we'll start there. Here I have three graphs. Determine whether each graph is the graph of an even function, an odd function. This should be the word and, not and, or neither. Okay, letter A. Is it an even function? Is it symmetric with respect to the y-axis? Does the right side map to the left side? Does the left side map to the right side? Obviously, the answer is no. This right side would end up over here as a hump above the x-axis. That's not the same. Okay, origin. If I put a pin, a tack, right at the origin, and I spin it, does it land on itself in less than a full circle? And the answer is yes. If I spin this one halfway around, this will be here and this will be here. Okay, so this function, this function is an odd function according to the graph. Okay, letter B. Even, odd, or neither. Well, even function, is it symmetric with respect to the y-axis? Here's the y-axis. Does the right land on the left? Does the left land on the right if we use this as our line of symmetry? And the answer is yes. Okay, so this is an even function. Okay, we can test odd, put a tack here and spin it, but it's going to require a full 360-degree spin to get back where it is. Okay, letter C, the graph of an even, odd, or neither. Well, again, here's my line of symmetry for even, the y-axis. Does the right side land on the left side and vice versa? The answer is no. There's nothing on the left side and there's something on the right side. So there's no way that I fold this and get the same thing. Origin, if I put a pin here at the origin and I spin it, I got to go all the way around in order to get back on itself. So this is a neither. Okay? Let's do it algebraically. Okay, we'll practice a bit more with our algebra. We did kind of some similar stuff in a previous video. Okay, algebraically determine whether each of the following functions is even, odd, or neither. Letter A, f of x is equal to x cubed minus 6x. Well, one of the things I mentioned in a previous video is when you have the function notation, it's a whole lot easier to replace it with just a y, so you can do this, okay? Whoops, I don't want to put that down yet. It's a lot easier to replace it with a y. Okay, let's first test even. Okay, now I'll replace it with the y. Y equals x cubed minus 6x. Okay, to test even algebraically, replace the x with a negative x and then see if you get the same thing. So let's replace the x with a negative x using parentheses so we don't lose track of our negative sign. This gives me a negative x cubed plus 6x. And guess what? Those two things are not equal, so this function is not even. Okay, is this function odd? Okay, odd means it is symmetrical with respect to the origin. So let's first copy down the original equation, replacing the f of x with a y to make our life a little easier. To test with respect to the origin, we replace y with negative y and x with negative x. And then we do a little manipulating. Negative y on the left, negative x cubed plus 6x. Multiply both sides by negative 1, and I get x cubed minus 6x. Hey, look at that. Same. So this is an odd function. I'll do this one on the graph. The other two you can do on the graph yourselves. We'll take a look at this one quickly on the graph. Okay. Y equals, clear out the previous in my case, x cubed minus 6x. So x cubed minus 6x. Let's graph this one. And you can certainly see it is not even. The y-axis is not a line of symmetry. It is definitely odd. If I put a pin at the origin and I spin it, it lands back on itself in 180 degrees, half a circle as opposed to a full circle. So this is an odd function. Okay, let's do two more examples. And again, I won't check with the calculator. You're welcome. I won't check it with the graphing calculator. You're welcome to do that on your own if you'd like to. Okay, this function is g of x is equal to x to the fourth minus 2x squared. Is it even? Well, if it's even, let's first off write it with a y. If it's even, I can replace the x's with negative x's and get the same thing. So let's test that. I'll put a negative x in for that x, minus I'll put a negative x in for that x using my parentheses so I don't lose negatives. And let's do the math. Negative x times negative x times negative x times negative x is positive x to the fourth. Okay, negative x times negative x is positive x squared, so minus 2x squared. And take a look at that. I got the same thing out. So this function is even. Okay, is this function odd? Hint, hint, there's only one function that is both even and odd, and I think it's the origin. I think it's f of x equals 0. I think it's the only function that is both even and odd. I don't believe there's any other function out there that is both even and odd except for the function that defines the origin. So this should come out to not be odd, given that those functions, there's no function that's both. Let's test it. Y equals x to the fourth minus 2x squared. To test for odd, whether it's symmetrical or about the origin, we replace both y with negative y and x with negative x, and then we do our math. Okay, well this is negative y on the left. This is positive x to the fourth minus 2x squared. Multiply both sides by negative 1, and I have y equals negative x to the fourth plus 2x squared. Well, these two are not the same, so it is not odd. This function is even. And again, you can test that with your graphing calculator. I will let you do that. Okay, the last one, the function h of x is equal to x squared plus 2x plus 1. Is it even, odd, or neither? Well, let's first test for evenness. I'll replace the h of x with a y to make my life a little easier. I don't want to carry around all that. To test for evenness, we replace the x with a negative x, so I'll use my parentheses to do that. Plus 2 times negative x plus 1. I'll do my math. Negative x times negative x is positive x squared minus 2x plus 1. I'll then compare. Well, the first term is identical. The third term is identical, but the second term, the term in the middle of this quadratic, is the opposite. So those two are not equal. It is not even. Now let's test odd. Okay, y is equal to x squared plus 2x plus 1. Okay, to test if a function is odd, that means it is symmetrical with respect to the origin, odd origin. And to do that, we replace both y with negative y and x with negative x. So negative y, and then replace x with negative x. And again, use your parentheses. Okay, left side is negative y, right side is x squared minus 2x plus 1. Multiply both sides by negative 1. Y equals negative x squared plus 2x minus 1. In this case, you can see that the middle term, positive 2x and positive 2x, are the same, but the first term and the third term are opposites, so those two are not equal. This is not odd. So this one happens to be neither even or odd. So there you have it, how to determine graphically and algebraically whether a function is even, odd, or neither.